First time ever an object from interstellar space has been observed to visit our solar system.
Amidst the interstellar space, mysteries abound. But none have captured the world's imagination quite like the inscrutable visitor known as Oumuamua. But when it first swept through our solar system in 2017, Oumuamua left scientists baffled and intrigued. Its bizarre cigar-like shape and unexpected acceleration raised countless questions. But now the visionary Elon Musk has boldly declared the return of Oumuamua with an escort. But what exactly is this cigar-like shape? Is it an asteroid, a spaceship, or something even more sinister and otherworldly? Join us as we venture into the unknown, guided by the visionary Elon Musk, to uncover the unimaginable and sudden return of Oumuamua. In October 2017, something remarkable occurred in our solar system. The University of Hawaii's Pan-STARRS, one telescope discovered an interstellar object, Oumuamua, near Maui's Haleakala volcano. This telescope is renowned for detecting space rocks, even faint ones like Oumuamua. Its official name was 1I/2017 U1, but the Pan-STARRS team gave it the poetic name Oumuamua, meaning messenger from afar arriving in Hawaiian. Oumuamua initially appeared as a reddish, elongated rock, resembling a giant cigar, stretching about a quarter-mile long, 10 times longer than its width. This extraordinary shape surpasses any asteroid or comet we've seen in our solar system. Its uniqueness could offer insights into other solar systems' formation. Detecting its extraterrestrial origin is simple, thanks to its incredible speed, exceeding the sun's gravitational pull. This distinct velocity distinguishes it from rogue Kuiper Belt objects. As Elon Musk points out, this rapid motion is a clear indicator of an object from beyond our solar system, making Oumuamua a fascinating interstellar traveler. Oumuamua sped past Earth at an astonishing 196,000 meters per hour, 109 times faster than a bullet, ruling out its origin from our solar system. Scientists initially couldn't decide if it was an asteroid or a comet. When it was zipped by the sun on September 9, 2017, it was called an asteroid. Later, slight acceleration hinted at comet-like behavior, but Oumuamua's unexpected speed puzzled scientists. Telescopes worldwide watched this cosmic visitor closely, revealing its oddities: no visible dust or comet tail, an elongated shape 10 times longer than wide, and a reddish hue like objects in our outer solar system. Oumuamua had been wandering our Milky Way for hundreds of millions of years. As it left our solar system, it accelerated unexpectedly, defying gravity's pull. This acceleration resembled a comet's boost caused by evaporating ice. However, Oumuamua's speed and trajectory didn't match predictions, raising questions about its peculiar path through space. Since its 2017 discovery, scientists have pondered Oumuamua's composition, origin, and its rapid 196,000 miles per hour speed. One theory suggests it might be solid hydrogen, turning into gas near stars, propelling itself like a natural ion engine. Some suggest it's disc-shaped due to its acceleration pattern, while others liken its behavior to comets in our solar system. Meanwhile, radiation pressure from sunlight could explain acceleration, but only if Oumuamua is exceptionally lightweight. Its unique shape and low density sparked lively debates among scientists. Some even speculated it could be an alien light sail crafted by an extraterrestrial civilization, though this was met with skepticism. Oumuamua's distinctive trait is its uncertain shape. While often depicted as a cigar, it may be more disc-like. We observed it from limited angles during its solar system journey, making its accurate proportions a mystery. The question of its nature continues to intrigue scientists. However, in October 2018, Dr. Shmuel Bialy and Professor Avi Loeb introduced a theory suggesting that solar radiation pressure could explain Oumuamua's strange acceleration. Their research, accepted for publication in the astrophysical journal Letters, proposed that Oumuamua's pancake-like shape and high reflectivity resembled a light sail. This sail-like structure could interact with radiation pressure, causing its acceleration and orbital deviation, similar to an interstellar explorer. This idea stirred both excitement and skepticism. Some sensationalized it as an alien origin theory, while others questioned its scientific basis. Professor Loeb defended his argument and authored a book delving into his controversial theory, aiming to engage both the scientific community and the general public in considering the possibility of Oumuamua as an extraterrestrial messenger. The book recounts his journey of presenting this contentious theory, urging readers to contemplate the potential of an extraterrestrial encounter. It provides a deeper exploration of his arguments, inviting further discussion on the mysterious Oumuamua's origins. Nonetheless, in 2018, as Oumuamua prepared to leave our solar system, the Hubble Space Telescope captured final images showing an unexpected increase in its speed. Scientists initially thought this could be due to outgassing, where material escapes from a comet's surface due to solar heating. However, Oumuamua had no visible tail, and its sudden acceleration puzzled experts since gravity should have slowed it down. Additionally, if outgassing had occurred, it should have caused Oumuamua to spin violently, which wasn't observed. Instead, researchers like Bialy and Loeb suggested radiation pressure as the likely cause for the speed increase. This raised the question, if Oumuamua wasn't a comet or asteroid, what could it be? The mystery continues to baffle scientists. Oumuamua's behavior left scientists puzzled as it defied natural explanations. Its brightness, shape, and acceleration couldn't be reconciled with existing theories, especially given the lack of outgassing. Musk believes that Professor Loeb's involvement in Project Starshot, which aimed to send a tiny spacecraft to Alpha Centauri propelled by a light sail and a powerful laser, played a role in shaping his hypothesis. When Oumuamua arrived, the idea of an interstellar probe clicked. Careful calculations supported this notion. To determine the probe's size, composition, thickness, and reflectivity, they analyzed all available evidence. Ultimately, everything pointed to a key idea: Oumuamua wasn't natural. While the light sail theory might seem unconventional, it followed a logical, evidence-based approach. Loeb and Bialy adhered to a scientific principle similar to Sherlock Holmes's detective work: eliminate the impossible, and what remains, no matter how unlikely, must be the truth. Thus, they proposed the hypothesis that Oumuamua was an artificial object, and Loeb presents this case by examining the limited evidence available. We can't definitively confirm if Oumuamua was an interstellar probe, but it's worth staying open to the idea. Elon Musk, who knows Loeb well, considers him a brilliant thinker. Loeb's interest in the search for extraterrestrial intelligence led him to propose the idea of Oumuamua as an alien spacecraft, a notion not widely accepted among his peers, but intriguing to him. Musk, too, hopes for alien life and is excited about the possibility, but advises caution against assuming aliens as the immediate explanation for unexplained phenomena. He mentioned that Loeb might have missed some research avenues due to limited knowledge at the time. While Loeb's theory is thought-provoking, it's important to consider it alongside other possibilities and continue exploring the mysteries of space. In an interview, Elon Musk discusses the mystery surrounding Oumuamua's trajectory near the Sun. He highlights that if an object doesn't follow gravity's rules, another force is at play. While possibilities like melting ice were considered, he's cautious about jumping to conclusions like aliens. Musk doesn't dismiss the idea entirely, but prefers not to immediately suggest extraterrestrial origins as the primary explanation. The question remains, what caused Oumuamua's unusual path? Similarly, in early 2020, researchers proposed a captivating theory about Oumuamua, suggesting it might be a hydrogen iceberg. They thought that pure hydrogen gas could propel it forward, like a rocket. While intriguing, this theory faced challenges upon closer examination. A paper authored by Harvard and the Korea Astronomy and Space Science Institute raised doubts about its viability. Professor Avi Loeb and others expressed skepticism due to several issues. A major problem was that the usual processes leading to solid objects, like Oumuamua, couldn't apply to a hydrogen iceberg. The typical method involves tiny dust grains sticking together through collisions. However, for a hydrogen iceberg of Oumuamua's size, the grains would have to collide and stick repeatedly, growing larger each time. But with higher gas density, these collisions generated excessive heat, instantly turning solid hydrogen into gas. Therefore, kilometer-sized hydrogen icebergs like Oumuamua couldn't form because the grains couldn't grow further. The researchers argued that the usual process of grain growth through sticky collisions couldn't work due to high gas density. Moreover, an object like Oumuamua couldn't have survived its long journey with a hydrogen iceberg structure. Such icebergs would evaporate rapidly during journeys lasting hundreds of millions of years. If the hydrogen ice theory were correct, it would have been groundbreaking, explaining Oumuamua's cigar-like shape and non-gravitational acceleration. However, scientists had more theories to explore, keeping the mystery of Oumuamua alive. In September 2020, a fascinating theory emerged about an elongated space rock known as Oumuamua. Imagine it as a colossal dust bunny, those clumps of dust and debris we find under furniture due to static electricity. Elon Musk explains that scientists considered Oumuamua as a giant version of this common household phenomenon. This peculiar space rock likely originated from a comet located beyond our solar system. According to this theory, Oumuamua formed when dust gradually blew off the comet's nucleus and gathered over the solar radiation, then pushed this rock through space, eventually bringing it on a brief tour within our solar system. The original comet, the parent of Oumuamua, was probably a long-period comet. These comets take a long time to complete their orbits around stars, often venturing far from them due to weak gravitational pull and radiation pressure. Oumuamua eventually separated from its parent comet, entering interstellar space. However, while this theory seemed convincing at the time, scientists later explored other ideas. Intriguingly, after a thorough 4-year investigation and the exploration of various theories, the astronomical community proposed a new explanation in March 2021. They suggested that Oumuamua could be a sizable fragment of nitrogen ice. This ice likely broke off from a distant solar system's Pluto-like exoplanet millions of years ago during its formation. This nitrogen iceberg theory offered a more natural explanation for Oumuamua's behavior, unlike earlier speculations about it being a rocky fragment from a planet torn apart by its star. These findings represented a significant shift from the initial extraterrestrial speculations that arose when Oumuamua was first detected. Initially met skepticism, the nitrogen iceberg theory gained support among astronomers, including those not involved in the study like Scott Shepard. They found it plausible that Oumuamua could be a piece of an icy dwarf planet. However, the case was not closed. In their research, scientists examined how different types of ice, made up of hydrogen, nitrogen, and oxygen, behaved under similar conditions. Surprisingly, they discovered that a significant chunk of nitrogen ice could exhibit the same characteristics as Oumuamua. The challenge was measuring nitrogen gas, which telescopes at the time struggled with. These studies identified Oumuamua's tail-like feature similar to what a comet would have, but it went undetected because of its nitrogen composition. According to Musk, the researchers also pinpointed potential sources of nitrogen icebergs, such as dwarf planets and objects at the outer edges of solar systems like Pluto and Neptune's moon, Triton. These bodies are known to have nitrogen ice on their surfaces. Elon Musk explains further, saying, based on their findings, the authors proposed that during the early stages of a distant solar system's formation, collisions between planetary bodies occurred, leading to the detachment of a nitrogen chunk. This theory sheds light on the mysterious origin and behavior of Oumuamua. A nitrogen iceberg ventured into our Milky Way over time. As it got closer to the sun, it wore down and ended up looking like a flat pancake. This idea, proposed by scientists, matched what they saw well. Even other astronomers thought it made sense and praised how it explained things. However, this idea had some holes. Professor Avi Loeb and Amir Siraj presented a different argument. They said that finding Oumuamua suggests there are many more like it in our galaxy. But if we assume that things like Oumuamua are entirely made of nitrogen from exoplanets, there should be a lot of exoplanets to make them. The count of exoplanets in our galaxy, though, is very low. This led to two possibilities. Either Oumuamua isn't entirely made of nitrogen, or we were way off in estimating the number of exoplanets. To solve this puzzle, researchers checked if there was enough stuff in the Milky Way to make all these nitrogen icebergs. It turns out that for so many to exist, the stars they formed around would need a lot of extra material to create them in the first place. This material is like a cosmic savings account, showing how much stuff is available for things like celestial icebergs around stars. Musk discovered that for our galaxy to make as many nitrogen icebergs as it does, it would need to transform 10 times the mass of all the stars into something called exoplutos. But even if we dream big, a star system can't have enough nitrogen ice to create so much exoplutos. To make matters worse, Musk believes that cosmic rays wear away interstellar objects like Oumuamua over time. If we include this in the equation, our galaxy would need thousands of times more mass than it has now. The response paper concluded that nitrogen can't be the hero anymore. However, not everyone agrees on how often objects like Oumuamua cruise through our galaxy. Some scientists think they're rarer than we thought. Professor Loeb suggests a high density, saying there's more than one interstellar object for every 10 cubic astronomical units. Others argue it's rarer, with one object for every 333 astronomical units. To put that in perspective, a single cubic astronomical unit equals 804 sextillion, 357 quintillion cubic miles, and 8 followed by 23 zeros. The choice of density dramatically alters the calculations. If you go with the latter, the nitrogen ice theory still makes sense. Nevertheless, scientists turned their attention back to hydrogen as a possible explanation for Oumuamua's traits and origin. In March 2023, a study by two astronomers shed light on the mystery surrounding Oumuamua. Using chemistry principles, they uncovered that Oumuamua was indeed a comet, albeit with an unconventional composition. Their theory suggests that Oumuamua picked up and held on to hydrogen gas due to cosmic radiation over millions of years. According to their modeling, Oumuamua might have begun as a typical water-rich comet orbiting a nearby star before getting flung out of its system. Throughout its journey through interstellar space, cosmic rays emitted by things like supernovae could have converted up to 30% of the comet's water ice into hydrogen. This hydrogen gas got trapped within Oumuamua's icy structure. When it got close to the sun, the heat caused the trapped hydrogen gas to escape, acting like a jet engine. In Musk's opinion, he said this unexpected acceleration explained Oumuamua's strange behavior as it departed. Astronomers hailed this model as one of the most convincing explanations for Oumuamua to date, showing that it wasn't so different from comets in our solar system. The researchers also found studies from 40 years ago that demonstrated how high-energy particles, like those in cosmic rays, could extract hydrogen from water ice and keep it within icy structures. According to Elon Musk, this theory fits perfectly with what we'd expect from interstellar comets. Some astronomers found it satisfying and straightforward, unlike other speculative ideas such as hydrogen icebergs. It helps solve the mystery of Oumuamua's behavior and composition, making it less alien than previously thought. While some scientists question this explanation, Professor Avi Loeb disagrees with the study's findings. He argues that they made errors in calculating Oumuamua's surface temperature, which led to an incorrect estimate of the available hydrogen in the iceberg. According to Loeb, this means that the outgassing of available hydrogen wouldn't explain the observed acceleration. Currently, Oumuamua is too distant for further measurements, and its return for examination is unlikely. However, astronomers remain hopeful that future sky surveys will reveal more interstellar objects like it. The Pan-STARRS. One telescope, which first spotted Oumuamua in 2017, captures high-quality images of the entire sky every 2 to 3 days. This technology allowed the detection of extremely faint objects, including Oumuamua. Given the swift motion of such objects, efficient sky coverage is essential since the observation window for Oumuamua in our solar system lasted only a few weeks, Musk said. So far, astronomers have confirmed the presence of only 2 interstellar interlopers, Oumuamua in 2017 and Borisov in 2018. Yet it's widely believed that many more exist. Unfortunately, scientists have had limited opportunities to study these objects once discovered. Musk opines NASA sees great potential in the James Webb Telescope, which could revolutionize our ability to study interstellar interlopers. Elon Musk believes that this powerful telescope will offer unprecedented insights into their chemical compositions, origins, formation processes, and the conditions in their home systems. It promises to expand our understanding of the vast cosmos and provide valuable insights into these celestial wanderers. Interstellar objects like Oumuamua are like hidden treasures of cosmic knowledge. The James Webb Telescope, a space observatory, promises to unlock their secrets. Studying these cosmic wanderers is vital because Oumuamua passed through our solar system so briefly, offering only a glimpse. Detecting and examining more objects like Oumuamua can confirm or refute various scientific theories about their origins. But what about visiting them? Some are enthusiastic about the idea of reaching these interstellar interlopers. Scientists have a plan to study them as they traverse our solar system. The consensus is that collecting a sample from these objects would be a remarkable achievement. One proposal involves launching a rocket into orbit and waiting for an interstellar object to pass by. The European mission called Comet Interceptor aims to do just that, stationed around the Moon's orbit, ready for the next Oumuamua-like visitor. Speaking of Oumuamua, its discovery was a milestone for humanity, marking the first direct evidence of interstellar objects after decades of theoretical speculation. However, as of March 2023, Oumuamua has ventured far beyond Neptune's orbit, heading towards the Pegasus constellation, never to return. It's now too distant for our telescopes to provide meaningful observations. The puzzle of Oumuamua's origin remains unsolved. Initial calculations suggest it likely came from the general direction of the bright star Vega some 300,000 years ago. However, Vega wasn't where it is now back then, and even if Oumuamua traveled at speeds of up to 59,000 miles per hour when it entered our solar system, it couldn't have covered this immense distance in a short time. So the true origin of Oumuamua remains a mystery. Thanks for watching another episode of Voyager. While you are still here, make sure to click the video on your screen for more quality content.